Across the silent darkness between galaxies, two great spirals drift toward one another. Silent, patient, inevitable. For billions of years, Andromeda has loomed on the horizon of our night sky, its faint glow whispering of another island universe beyond our own. But recently, astronomers have pierced its veil of mystery. For the first time, we finally know its true mass, and what they found changes everything we thought we knew about our cosmic home. Because the truth is humbling. Andromeda is far more massive, more ancient, and more influential than we ever imagined. How heavy is an entire galaxy? And what does Andromeda's weight mean for the fate of the Milky Way? Like and subscribe, and join us as we drift across the void. Let's begin. For most of human history, Andromeda was nothing more than a blur, a smudge of light mistaken for a nearby cloud. Yet hidden within that faint shimmer lies over 1 trillion stars. Our closest galactic neighbor, quietly orbiting us in a slow cosmic dance, has been approaching for billions of years. Now, we finally understand how much mass fuels its motion. If you step outside on a clear, moonless night and look toward the constellation Andromeda, you might just see it. A faint, misty oval hanging above the horizon. No telescope required, no special equipment. That glow is light that left Andromeda 2.5 million years ago, before the first humans ever walked the Earth. It drifts through time and space to reach your eyes, a silent message from a neighboring island of stars. You are seeing another galaxy, the closest large one to our own, and with it, a glimpse of our cosmic twin. For centuries, astronomers argued about what that faint patch really was. In the early 1600s, Galileo turned his telescope toward it and saw countless tiny points of light, suspecting it was a cluster of distant stars. Later, in the 18th century, Charles Messier catalogued it as Messier 31, a nebula, a fog of cosmic dust within the Milky Way. No one yet understood its true scale. It would take until the 1920s, when Edwin Hubble measured the light of its stars, to reveal the shocking truth: Andromeda wasn't a cloud in our galaxy. It was another galaxy entirely, one of billions. From that moment on, Andromeda became more than a curiosity. It became a mirror. Its spiral arms, its bright core, its clusters of stars, all echoed the structure of our own Milky Way. For the first time, we saw that we were not alone in the universe of galaxies. Ours was just one of countless islands floating in an endless cosmic sea. And in that sea, Andromeda is our nearest neighbor and our future companion. The light we see today left Andromeda long before our species discovered fire. In that time, the galaxy itself has been moving, inching closer to us every second. At roughly 110 kilometers per second, it's on a direct collision course with the Milky Way. Two great spirals, drawn together by the invisible threads of gravity, approaching in slow motion over billions of years. You could say we are already falling toward each other, a fall so vast and gentle that no one alive today, or in 1,000 generations, will notice the change. Andromeda is not just near in distance, it is near in fate. Its gravity subtly tugs at the outskirts of our galaxy, stirring the thin streams of stars at the edge of the Milky Way. Each of those stars traces an ancient gravitational bond, connecting us to a neighbor that we will one day merge with. When that day finally comes, in 4 billion years, the two galaxies will blend into one, a single, giant, elliptical galaxy shining brighter than anything our night sky has ever known. Until then, Andromeda remains our silent companion, gliding closer through the dark, patient and immense. It is a neighbor that reminds us how connected all things are, even across millions of light years. Its faint light whispers a truth both humbling and beautiful, that even across the gulfs of space, we are never truly alone. Measuring the mass of a galaxy is like trying to weigh a storm. Stars move, gas flows, and invisible forces shape everything. For decades, astronomers relied on guesswork, counting starlight, estimating gas. But Andromeda hides most of its weight in something we can't see: dark matter. When you look up at that soft blur in the constellation Andromeda, you're seeing only its surface, the glimmering skin of a creature far larger than its light suggests. Beneath that luminous face lies a vast, invisible architecture of gravity. Trying to know how heavy it truly is would be like standing on the shore of an ocean and guessing its depth from the color of the waves. The surface deceives. The real story is buried in motion. Astronomers learned long ago that gravity leaves fingerprints everywhere. Each star that circles Andromeda's core carries a secret. Its speed tells how strong the galaxy's pull must be. The faster a star moves, the heavier the galaxy must be to keep it from flying away. So scientists began to measure those motions carefully, watching how the outer stars behaved compared to the inner ones. Logic said that the farther a star lies from the center, the slower it should orbit, just as Neptune drifts around the Sun far more leisurely than Mercury does. At the galaxy's edge, where starlight fades into darkness, the outermost stars raced on at astonishing speed, as if gripped by an unseen hand. There wasn't enough visible matter, no combination of stars, gas, or dust to explain their motion. It was as though a hidden mass, vast and all-encompassing, were holding everything together. And thus, the concept of dark matter moved from theory into necessity. Imagine it, a halo of invisible substance stretching hundreds of thousands of light years beyond what any telescope can see, outweighing the visible galaxy by nearly 10 to 1. We cannot photograph it, cannot touch it, yet every star we see owes its orbit to that darkness. To weigh Andromeda, scientists combined every clue they could find: the rotation of its stars, the drift of its satellite galaxies, the glow of its surrounding gas. Each measurement added a new brushstroke to the same revelation. Most of the galaxy's weight is hidden. The light we see is only the frosting on a much deeper, denser cake of gravity. There's something poetic in that idea, that what defines a galaxy is not the brilliance of its stars but the gravity of its unseen heart. The cosmos reminds us that appearances are never the full story. What we cannot see may be the very thing that keeps everything from falling apart. Tonight, as we lie beneath our own spiral of stars, the Milky Way hums with the same secret. We, too, are held together by an invisible hand, orbiting inside a halo of mystery. And somewhere out there, Andromeda's hidden weight is answering back, its gravity tugging gently across the void, preparing for a meeting written long before any of us looked up to measure it. In 2024, a breakthrough in measuring stellar motion revealed the full extent of Andromeda's gravitational pull. By tracking hundreds of globular clusters and satellite galaxies, scientists reconstructed its unseen mass, and what they found shocked even them. For decades, astronomers had peered into the faint mist of Andromeda and tried to read its secrets in motion. They measured the flicker of stars, the shimmer of hydrogen gas, the slow waltz of star clusters bound to its gravity. Yet every attempt to map its weight ended in uncertainty. Was it heavier than the Milky Way, or lighter? The question lingered like a soft hum across the decades, a riddle suspended in the dark. Then came the era of precision. The European Space Agency's Gaia mission began charting the heavens with a sensitivity never seen before. Gaia measured the position and motion of over 1 billion stars in our galaxy and beyond, transforming the sky from a static map into a living, breathing film of motion. With Gaia's data, scientists could finally trace how entire galaxies drift and turn in the fabric of space. When researchers turned Gaia's gaze toward Andromeda, they uncovered patterns no telescope had ever captured. They watched tiny satellite galaxies orbiting the giant like moons, moving under the spell of its hidden gravity. Each orbit became a clue, a fingerprint pressed into the fabric of space-time. From those motions, scientists rebuilt the invisible, an image of Andromeda's gravitational halo, its reach, its power, its depth. The numbers that emerged were staggering. Andromeda was not the near twin of the Milky Way we once imagined. It was the heavyweight of the local group, its total mass approaching 1.5 trillion suns. That figure didn't just revise our models, it rewrote them. The two great spirals were no longer equal partners in a cosmic duet. One was leading, and the other was following. This revelation meant more than just numbers. It revealed fate. The stronger Andromeda's gravity, the sooner our two galaxies will merge. Their meeting is not a collision in the ordinary sense, no fiery crash, no shattering sound, but a merging of stars, a slow weaving of two spirals into one luminous whole. Andromeda's newfound mass means that the great encounter may arrive 500 million years earlier than we once thought. It's humbling to imagine that such a discovery, the fate of galaxies, could come from measuring the trembling light of stars millions of light years away. Every data point, every pixel of light, became a syllable in a cosmic language that scientists learned to read. Through them, the universe whispered its truths, that mass shapes destiny, that gravity writes time itself, and that even from across the void, Andromeda's presence has already begun to alter our path. Surrounding Andromeda is a colossal, invisible halo of dark matter, stretching millions of light years into space. This halo alone outweighs the visible galaxy by nearly 10 to 1. Like an unseen ocean, it holds the stars, planets, and gas clouds in its cosmic grip. If Andromeda's brilliant spiral arms are the waves on the surface, the halo is the deep sea beneath. Silent, invisible, yet defining everything above it. For decades, astronomers suspected its existence. But it was like trying to describe the wind by watching leaves tremble. Only in recent years have new instruments allowed us to trace this unseen structure through its faint fingerprints on the light of distant quasars. Quasars, the blazing hearts of ancient galaxies, act like lanterns shining through fog. As their light passes through Andromeda's halo, it's subtly absorbed by the gases drifting there. Oxygen, carbon, silicon, and other elements forged in long-dead stars. By studying those delicate absorption lines, scientists could finally chart the invisible. They found a halo so vast that if we could see it glowing in the sky, it would stretch across a region 6 times wider than the Moon. This enormous shroud is made of hot, diffuse plasma, heated to millions of degrees, the remains of supernovae and galactic winds expelled over billions of years. It's where Andromeda's past lingers and its future begins. That halo is not empty. It contains the raw materials for new stars, the ashes of old ones, and the heavy elements that one day could form planets, atmospheres, and even life. More astonishing still, the halo extends far enough to overlap with that of the Milky Way. Our galaxies, though separated by 2.5 million light-years, are already touching, not in light, but in gravity. Their halos are mingling in silence, an unseen handshake between cosmic giants. To understand the halo is to understand the skeleton of the universe. It's the scaffolding of creation, the structure that binds galaxies, stars, and time itself. Without it, galaxies like Andromeda could not exist. Their stars would simply fly apart, their light scattered into emptiness. In the halo's quiet vastness lies an elegant paradox, that what defines a galaxy most profoundly is what we cannot see. Its darkness holds its light, its emptiness gives it form, and somewhere within that invisible ocean, our own galaxy's edges are already dissolving into Andromeda's embrace, the first ripple of a meeting that has already begun. Andromeda contains roughly 1 trillion stars, more than twice the number in our Milky Way. Each of those suns, each with its own worlds, adds to the unimaginable weight of this galactic colossus. To the naked eye, Andromeda is just a faint smear of light, but through a telescope it becomes a living city of stars, dense, bright, and endlessly sprawling. Its glowing core blazes with the accumulated light of ancient suns packed shoulder to shoulder, so close that darkness never truly falls. From there, its spiral arms unwind like rivers of fire, filled with blue-white stars newly born from clouds of gas and dust. Between those arms drift lanes of shadow, dust dark enough to swallow starlight whole, yet rich enough to seed entire generations of new suns. Imagine it from within, standing on a planet orbiting one of those stars, looking up into a sky more crowded than any dream. Thousands of suns would shimmer across the heavens, each one close enough to cast a shadow. Night would never be dark, only a deep, endless twilight of color and warmth. That is Andromeda's reality, a realm of ceaseless light, a trillion voices singing the same cosmic song. Every star there has lived a different life. Some burn with the youthful blue of new fire, others with the golden calm of middle age. Many are old red giants, swollen and fading, carrying the history of a galaxy that began forming shortly after the dawn of time. Each one contributes to Andromeda's weight, not just through its matter, but through its gravity, its radiation, its story. Together, they form a gravitational chorus that shapes the entire spiral. The combined light of these stars is so bright that even from 2.5 million light-years away, it reaches Earth unaided, a whisper from a trillion suns traveling across cosmic night to find our eyes. That light left Andromeda before humans existed, before the first sparks of civilization, yet it continues its patient journey, arriving still, steady, and soft. And yet, for all its brilliance, the stars account for only a fraction of Andromeda's mass. Most of what makes the galaxy what it is lies hidden in dark matter and gas. The stars are its visible skin, glowing against the dark, the part we can see of a story far larger and deeper than light alone can tell. To gaze at Andromeda is to look into a mirror of possibility. A trillion suns, each one perhaps with its own worlds, its own skies, its own dawns. Somewhere out there, light is falling on alien oceans, on rings of ice, on mountains beneath foreign constellations, and all of it, every shining world, every silent orbit, belongs to the same galaxy drifting toward us, a trillion suns moving as one, across the dark sea of time. Most of Andromeda's mass comes not from light, but from darkness. Dark matter, the mysterious substance that neither emits nor absorbs light, makes up nearly 90% of its total weight. Without it, the galaxy would fly apart. If you could see Andromeda not with your eyes, but with your mind, you'd witness something extraordinary. A colossal spiral of stars floating in an invisible sea, held together by gravity born of nothing we can touch or see. The visible galaxy, its glowing arms, its radiant core, is just a trace of light drifting through a far larger shadow. That shadow is dark matter. We don't yet know what dark matter truly is. It doesn't shine, doesn't collide, doesn't behave like the matter that forms planets, stars, or you. And yet, it shapes everything. It is the silent scaffolding upon which galaxies are built. Without it, Andromeda's spiral arms would unravel like loose threads, its stars flung into intergalactic night. But instead, they remain bound, circling endlessly, sustained by gravity's invisible hand. Astronomers discovered dark matter's influence not through sight, but through defiance, through galaxies like Andromeda, refusing to obey the rules of physics as we once understood them. When scientists calculated how fast Andromeda's stars were moving, they realized that visible matter alone couldn't account for their speed. There wasn't enough mass in all its shining stars and glowing gas to hold them in place. Something unseen was providing the missing gravity. That something must be vast beyond comprehension. The halo of dark matter enveloping Andromeda stretches for millions of light years, a cosmic cocoon that outweighs every star in the galaxy tenfold. It bends light, sculpts orbits, and governs the paths of smaller galaxies that wander near. Every faint cluster, every wisp of hydrogen gas, dances to its pull. The realization that most of Andromeda's mass is invisible reshaped our view of the universe. It means that everything we can see, every planet, every sun, every glowing nebula, makes up less than 10% of reality. The rest lies hidden in the dark. We live in a universe where the unseen outweighs the seen, where the silence is heavier than the song. Dark matter is not simply the glue that holds galaxies together. It is the framework of existence. It defines how galaxies form, how they move, and even how the universe will end. Andromeda's immense, invisible halo reminds us that light alone cannot tell the whole story. The cosmos hides its deepest truths in shadow. When we look at Andromeda through a telescope, we're not just witnessing light from another galaxy, we're peering into the outline of a mystery that defines us. The darkness around it is not emptiness, it is structure, substance, and strength. The stars shimmer, but it is the dark that holds them steady. To weigh a galaxy, you don't count its stars, you watch how they move. By measuring how fast Andromeda's stars orbit its center, scientists can calculate the mass needed to keep them in place. The faster they move, the heavier the galaxy must be. It's a strange kind of weighing, one that uses light and time instead of scales and numbers. In the silence of space, motion becomes the only language gravity speaks. And by learning to read it, astronomers have turned Andromeda's light into a story about mass, energy, and cosmic balance. When a star orbits the heart of a galaxy, its motion is dictated by the total gravity around it. Too little mass, and it would drift away forever. Too much, and it would spiral inward, swallowed by the black hole at the center. So, by measuring the speed of those stars, how quickly they circle, how far they are from the core, scientists can reconstruct the invisible hand guiding them. To do this, they use a phenomenon called redshift. When a star moves away from us, its light stretches into longer wavelengths, drifting toward red. When it moves closer, it shifts toward blue. By measuring these tiny changes in color, astronomers can calculate how fast a star is moving, even across millions of light years. In Andromeda, the pattern is mesmerizing. Its stars rotate with a kind of serene defiance, the outermost ones moving just as swiftly as those near the center. This was one of the first signs that something beyond visible matter was at work. According to Newton's laws, those faraway stars should have slowed down, their orbits loosening as they ventured beyond the galaxy's bright disk. Instead, they raced on, bound by gravity far stronger than what light alone could explain. That was the birth of a new understanding that galaxies are not held together by their visible mass, but by a halo of dark matter extending far beyond what telescopes can see. The motion of Andromeda's stars became evidence written in starlight, an unspoken confession of hidden weight. Through decades of observation, astronomers charted these motions with exquisite precision, using instruments like the Hubble Space Telescope and Gaia to record the delicate trembling of light across time. Each data point, each orbit, each curve of velocity painted a clearer picture of the galaxy's immense gravitational field. To weigh Andromeda is to measure motion, to listen for the rhythm of its stars as they circle the void. It's an act of cosmic patience, a science of silence and light. In the end, it tells us something profound, that movement, even in the farthest reaches of the universe, is a record of presence. It holds, therefore it is heavy. We cannot touch Andromeda, but through its motion, we can feel its weight, not in our hands, but in the numbers, in the glow, in the gravity that bridges the dark between worlds. After decades of uncertainty, new data revealed the answer. Andromeda's total mass is about 1.5 trillion times that of the Sun, enough to bend the trajectories of smaller galaxies and shape the structure of our local universe. It's almost impossible to imagine what that means. 1.5 trillion suns, each one massive enough to anchor its own solar system, combined into a single gravitational entity. If you could somehow gather all that mass into one point, its pull would be so great that light itself could not escape. And yet, instead of collapsing, Andromeda spreads its enormity across 220,000 light-years of space, a vast, delicate balance between gravity and motion. This revelation didn't come easily. For generations, scientists wrestled with estimates that swung wildly between optimism and caution. Early observations from Earth-based telescopes hinted that Andromeda might be slightly smaller than the Milky Way. Later data, collected from radio waves and X-rays, suggested the opposite. It wasn't until the advent of precise space observatories, Gaia, Hubble, and the Chandra X-ray Observatory, that the truth began to emerge with clarity. By tracking the motion of Andromeda's satellite galaxies, small companions like M32 and M110, astronomers mapped the reach of its gravity. They watched how those tiny galaxies orbited the larger one, their paths curved not by visible matter, but by the vast, invisible halo surrounding it. The farther they looked, the more they realized that Andromeda's gravitational hand extended far beyond what light revealed. The result? A total mass of roughly 1.5 trillion suns. It's a number so immense it feels abstract, but its implications are tangible. It means Andromeda exerts a gravitational influence that spans nearly half the width of the local group, the small cluster of galaxies that includes our own. It means that the Milky Way's fate is already entwined with it, bound by the pull of a shared future. Andromeda's mass is not just a statistic, it's a declaration of dominance. It shapes how nearby galaxies drift, how clusters form, how intergalactic gas flows through the cosmic web. Its sheer presence distorts the very geometry of space-time around it, a silent curvature written into the void. Knowing Andromeda's true weight gives us more than just numbers. It gives us perspective. It reminds us that even the largest things in the universe are measurable, that patience and observation can turn mystery into understanding, and it teaches us something beautifully humbling, that the gravity of Andromeda, this distant island of light, reaches all the way to us, pulling gently, persistently, across millions of years, like the slow beat of the universe's heart. Andromeda isn't just our neighbor, it's our reflection. Nearly identical in shape, size, and age, it offers a glimpse into our own galaxy's past and future. Understanding Andromeda means understanding ourselves. When we look at Andromeda, we're not only seeing another galaxy, we're looking into a cosmic mirror. Its spiral arms, its radiant bulge, its halo of dark matter, all echo the structure of our own Milky Way. They are like twin cities separated by the vastness of intergalactic night, each shaped by the same cosmic laws, each drifting along parallel paths carved by gravity. Both galaxies were born from the same primordial turbulence nearly 13 billion years ago, when the universe was young and filled with clouds of hydrogen gas. In that chaos, gravity sculpted these clouds into disks of spinning stars. Over eons, they grew, colliding with smaller galaxies, consuming them, reshaping themselves into grand spirals. Each became a reflection of the other, evolving apart but following the same dance. When astronomers study Andromeda, they are, in a sense, studying us from afar. They see how its stars orbit, how its gas flows, how its black hole feeds at the center. Those observations reveal what our own galaxy might look like if seen from outside, something we can never do directly. Through Andromeda, we glimpse the Milky Way's own anatomy, its skeleton of starlight and shadow. The similarities go deeper still. Both galaxies host hundreds of billions of stars. Both contain vast clouds of dust and gas forming new generations of suns. And both are surrounded by halos of invisible matter that bind them together. Even their central black holes, each millions of times more massive than the Sun, mirror one another like dark twins, each anchoring its galaxy's heart. And yet, for all these parallels, subtle differences whisper through the comparison. Andromeda is slightly larger, slightly heavier, slightly older, as though we're looking at a sibling just a few million years ahead in time. Studying it is like glimpsing our own future written in the language of starlight. If we could trade perspectives, if we could see the Milky Way from Andromeda's sky, we would appear as they do to us, a delicate whirl of light across the dark, a luminous spiral against eternity. Between the two lies a bridge of gravity, invisible but unbreakable, pulling us together in a slow, patient embrace. Perhaps that's what makes Andromeda so haunting. It reminds us that the universe reflects itself, that we are not alone, not unique, but part of a repeating pattern, mirrored across the cosmos. Every time we look outward, we are also looking back at ourselves, written in stars. The Milky Way and Andromeda are locked in a gravitational embrace. Invisible threads of gravity pull them closer by the second. 110 kilometers per second, to be exact. Their collision is inevitable. Across the silent gulf of intergalactic space, two great spirals drift toward each other. Slowly but relentlessly. The distance between them, 2.5 million light-years, seems unbridgeable. A chasm so vast that light itself takes eons to cross it. And yet, gravity doesn't see distance the way we do. It reaches across the void like an unseen hand, tugging gently but persistently, binding these galaxies together in a union that cannot be undone. For billions of years, the Milky Way and Andromeda have been falling toward one another, caught in a mutual attraction that began long before Earth existed. Their orbits trace a slow, spiraling waltz around a shared center of mass, a cosmic choreography that has been unfolding for 10 billion years. Every second, they inch closer by 110 kilometers. To us, that speed seems unimaginable, yet on the scale of galaxies, it is the rhythm of inevitability. You cannot feel it, but with each heartbeat, the space between the stars narrows. And that space is not empty. It is alive with motion, thin rivers of gas, dust, and even rogue stars drifting between the galaxies. These faint, shimmering threads form a gravitational bridge, a delicate connection of matter stretching across millions of light-years. They are the first whispers of contact, the earliest strands of the collision to come. Already, their invisible halos, vast envelopes of dark matter, have begun to merge. Though we cannot see them, they overlap like translucent spheres, exchanging gravitational energy in silence. The galaxies themselves are still far apart, but their unseen borders are already touching. It's as if the universe itself is preparing for the embrace, aligning everything in slow, deliberate harmony. In this slow-motion dance, neither galaxy is the aggressor. Each one responds to the other, deforming slightly under the pull, their outer stars feeling the faint tug of a future written in gravity. Spiral arms stretch and twist, subtle distortions that reveal how deeply intertwined their fates already are. The closer they draw, the more their shapes will warp until the familiar outlines we know today are gone. What's remarkable is that this grand celestial encounter obeys the same simple laws that govern everything from falling apples to orbiting planets. Newton's equations, penned centuries ago, still describe this meeting of giants with perfect precision. And Einstein's geometry, the bending of space-time under mass, explains the slow, graceful curve of their attraction. To witness Andromeda's approach is to glimpse gravity's patience. It is a force not of violence, but of persistence, a reminder that the universe moves not in haste, but in harmony. What feels eternal to us is, to gravity, merely the steady unfolding of destiny. The Milky Way and Andromeda fall toward each other like lovers separated by time and drawn by fate, silent, steady, unstoppable. The outcome has already been written in the curvature of space. All that remains is for time to turn the page and let the dance reach its beautiful conclusion. The more massive Andromeda is, the sooner it will collide with us. Every new calculation brings the date closer, now estimated at just 4 billion years from now. The future of the night sky is already unfolding, quietly, invisibly, above our heads. Tonight, Andromeda is just a faint blur, a soft smudge of light adrift beyond the stars. But in the far future, the heavens will change, the smudge will sharpen, the glow will grow, and the galaxy will bloom before our eyes. 1 billion years from now, Andromeda will stretch as wide as the moon. 2 billion years, and its spiral arms will shimmer clearly against the dark. By 3, our galaxies will dominate the same sky, twin storms of light spiraling toward collision. And at last, in 4 billion years, they will meet. It will not be a cataclysm, but a transformation. The stars of both galaxies will pass through each other unharmed, separated by gulfs of emptiness so immense that collisions between individual stars will be rare. Yet gravity will weave its spell across every orbit, bending, twisting, reshaping. The spiral arms will distort, the galactic disks will stretch into vast tidal streams, and great clouds of gas will collide, compress, and ignite. New stars, millions upon millions of them, will burst into being, flooding the night with fresh light. For any surviving worlds, the sky will be unrecognizable. Where we now see constellations, quiet and familiar, future skies will blaze with rivers of fire. Nebulae will bloom across the heavens, and entire swaths of the firmament will shimmer with newborn suns. The galaxy merger will not destroy light, but multiply it. For a brief cosmic moment, the universe will burn brighter than ever before. This fate has been written since the beginning. From the moment both galaxies formed in the aftermath of the Big Bang, their mutual gravity began this long, slow pull. Every star in Andromeda, every planet in the Milky Way, every grain of dust and wisp of gas, all are following the same simple law: gravity pulls. It has no malice, no mercy, no haste. It simply draws, patiently, inevitably, until what was once apart becomes one. Andromeda's mass determines the rhythm of that story. The heavier the galaxy, the stronger its pull, and the sooner the dance will end. New measurements, placing Andromeda's mass at roughly 1.5 trillion suns, reveal that the merger will happen earlier than once thought. The countdown has already begun, though its clock ticks in eons, not seconds. When the moment comes, the two galaxies will merge into something entirely new, a vast elliptical supergalaxy that astronomers already call Milkdromeda. The night sky of that distant future will glow with the light of two galaxies made one, their stars woven into a single luminous tapestry. We will not be here to see it. Humanity, the Earth, even the Sun will likely be gone, but the universe will witness it, and in that merging, something profoundly poetic will occur. Two cosmic reflections, long separated by darkness, will become one. Their destinies, written across billions of years, will converge in a single act of creation. The Milky Way and Andromeda, twin spirals bound by the same gravity that shapes all things, will at last fulfill the promise, written in their mass, their motion, their pull, to meet, to merge, and to become eternal. When the two galaxies meet, they won't crash like solid objects. They'll merge like waves, stars passing harmlessly through vast emptiness, while gravity reshapes them into a single, magnificent new supergalaxy, Milkdromeda. From our perspective, this grand event will unfold in the slowest motion imaginable, a cosmic ballet written across billions of years. Even now, Andromeda drifts toward us through the quiet dark, its spiral arms unfurling like open hands. The Milky Way spins too, carrying us along through its glowing lanes of starlight, unaware of the destiny already written in the space between. One day, these two spirals, cousins born from the same ancient dawn, will touch, and the universe will rearrange itself around their meeting. When that moment comes, there will be no explosion, no sudden chaos. Instead, they will pass through one another like spirits through mist, their light crossing paths without ever making contact. Yet this meeting will be anything but gentle. Clouds of gas and dust, the fertile nurseries of stars, will collide, compressing and heating until fusion ignites. The galaxies will erupt in waves of creation. Shock fronts will ripple outward through both galaxies as gravity forces matter to collapse into new stars. Vast clusters will burst to life, shining blue and white, their brilliance outshining all that came before. For a brief cosmic epoch, the night skies of any surviving worlds will blaze like never before, a billion newborn suns painting the heavens with fire. From those distant worlds, the view will be breathtaking. Andromeda will rise like a luminous storm, its spiral arms stretching from horizon to horizon. The night will no longer be dark, it will shimmer with motion, stars streaming across the heavens in rivers of light, their paths bending, twisting, and joining in intricate spirals of transformation. Over millions of years, the two galaxies will intertwine, their arms torn into delicate threads of starlight, wrapping around one another like silk ribbons caught in the wind. But even in the chaos, there will be order. Gravity, ever patient, will smooth the turbulence, knitting the chaos into something new. The elegant spirals will slowly fade, their once distinct arms dissolving into a rounded halo of stars. What emerges will be vast and luminous, a single, elliptical galaxy glowing softly against the black, serene and complete. Astronomers have already given it a name: Milkdromeda. At its center, two titans, the supermassive black holes of the Milky Way and Andromeda, will spiral inward, dancing a final waltz before merging into one. When they collide, they will release an immense burst of gravitational waves, rippling through the fabric of space-time itself. For a fleeting moment, the universe will ring, not with sound, but with motion, a deep, cosmic note echoing through eternity. Then, silence will return. The newborn galaxy will settle into balance, its stars orbiting in quiet harmony. What once were two separate worlds will have become one, brighter, heavier, and filled with the recycled light of billions of suns. The Great Galactic Merger is not an ending, but a renewal, a reminder that in the universe, destruction and creation are one and the same. Stars die, galaxies collide, atoms scatter and reform. Yet the cycle continues, endlessly, beautifully. Long after we are gone, our atoms, forged in ancient suns, will still drift within this grand process, part of the same universal rhythm. And when Milkdromeda finally settles, it will carry the memory of its parents in every star. Half born of the Milky Way, half of Andromeda, all woven into a single, glowing whole. In that union lies the quiet truth of the cosmos, that everything that drifts apart will one day meet again, and in meeting, become something greater. Long before the collision, Andromeda's gravity has already begun tugging at the Milky Way's outer stars. Streams of lost suns stretch between the galaxies, silent, glowing evidence of their growing attraction. The space between galaxies isn't empty. It is a quiet ocean of invisible tension, a cosmic web woven from gravity's pull. Across this web, matter drifts, not aimlessly, but guided by unseen hands. In that vastness, stars wander. At the fragile edges of the Milky Way, far beyond the bright whirl of our stellar disk, Andromeda's gravity is already reaching out. Its pull gently lifts suns from their ancient orbits, drawing them outward into long, faint streams that stretch toward the approaching spiral. Each of those streams is a whisper from the future, the first touch between two galaxies destined to unite. Astronomers have begun to see the signs. Using the Gaia spacecraft, they've mapped delicate rivers of stars, faint, thread-like filaments crossing the dark. These are the remnants of smaller galaxies, once whole, now torn apart by gravitational tides. Their stars spill into space like luminous dust, tracing the arcs of motion that reveal the hidden structure of the cosmos. Some of these streams already curve toward Andromeda, glowing trails marking the ancient bridge that gravity is building between us. Each lost star carries a quiet story. Once, it circled the Milky Way in serenity, part of a system of order and light. Now, it drifts between galaxies, an exile caught between titans. Over billions of years, it will travel across intergalactic space, following a path shaped by forces it can never escape. These wandering suns are the first emissaries of the coming union, heralds of a collision that has already begun, though we cannot yet feel it. Andromeda bears its own scars. Around its edges, astronomers have traced vast, looping arcs, remnants of galaxies it has consumed. These ghostly ribbons wrap around it like silk caught in a cosmic breeze, glowing faintly with the light of ancient stars. Each trail is a memory, a record of something smaller that once was, now folded into something greater. They are the fingerprints of gravity's appetite, showing us that galaxies are not static structures, but living entities that grow, devour, and transform. If we could see gravity instead of light, the night sky would shimmer with connection. Between Andromeda and the Milky Way, a vast, radiant bridge would appear, not of solid matter, but of potential, of movement, of pull. Stars would stream across it like dust in a current, drawn ever so slightly toward a shared destiny. The bridge would ripple, alive with motion, like two tides converging in the stillness of deep time. Every one of those drifting stars is a thread in a larger design, each a spark of light woven into the tapestry of becoming. They show us that the merger is not something that will happen. It is something already unfolding, softly, invisibly, all around us. The galaxies are not waiting for the future. They are building it, star by star, stream by stream. The collision, when it finally arrives, will not be a beginning, but a continuation, the culmination of a process that has been in motion for eons. The universe rarely leaps, it glides, it merges, it transforms. And in those silent rivers of light stretching across the void, we can already glimpse the shape of that future. The faint, delicate handwriting of gravity, spelling out what will come. Around Andromeda orbit over 30 smaller galaxies, tiny companions bound to its immense gravity. Each one is a clue to the galaxy's invisible architecture, tracing the outline of its vast, dark matter halo, like drifting embers marking the edge of a hidden fire. They are faint, ancient, and easily overlooked, fragile smudges of light adrift in the deep black of space. To the naked eye, they are invisible, but under the gaze of powerful telescopes, they appear like scattered fireflies caught in orbit around a great lantern. These dwarf galaxies, some containing only a few million stars, circle Andromeda as moons circle planets. They are fossils of a younger universe, survivors of cosmic collisions, relics of an age when the first galaxies were still learning to form. Each satellite's motion is a kind of language. As these dwarfs trace their orbits, their paths whisper secrets about Andromeda's true mass, about the reach and rhythm of its dark halo. By measuring how fast they move, astronomers can infer how much unseen matter holds them in place. The faster they orbit, the stronger the pull must be. The slower, the gentler the grasp. Each faint smudge becomes an instrument of cosmic measurement, a pendulum swinging to the beat of gravity. Together, they draw an outline of something we cannot see. The ghostly sphere of dark matter surrounding Andromeda, stretching millions of light-years beyond its glowing disk. Some of these companions are faintly visible even through small telescopes, M32 and M110. Andromeda's best-known satellites glow as tiny elliptical blurs near its spiral arms. Others are nearly invisible, their light so weak that only with modern digital imaging can they be found at all. Galaxies like Andromeda's Ovenites and Andromeda XXV, dimmer than the darkest corners of the Milky Way. Many are in the process of being torn apart, their stars stretched into thin streams that will one day spiral into Andromeda's halo. Gravity feeds on patience, and Andromeda is a patient host. It slowly consumes these companions, weaving their stars into its own fabric, recycling them into new suns, new clusters, new beginnings. These satellites remind us that galaxies rarely exist in solitude. Like planets and moons, they come in families, hierarchies bound together by gravity's eternal pull. The Milky Way, too, has its own entourage, the Magellanic Clouds, the Sagittarius Dwarf, and a dozen smaller companions drifting quietly at its edge. Together, these systems form a network of relationships that stretches across millions of light-years, a celestial genealogy written in orbits and mass. But the dwarfs around Andromeda hold something special: memory. Some formed in the earliest epochs of the cosmos, before Andromeda's spiral arms ever took shape. Their stars are ancient beyond reckoning, among the first to burn after the Big Bang. Others are the hollowed remains of once proud galaxies, stripped bare by Andromeda's relentless tides. They orbit now as ghosts, carrying within them the record of collisions, of births, and of endings long past. Through them, we see Andromeda not as a lone entity, but as a family, a constellation of smaller galaxies moving together through the dark, each one following the pull of an unseen hand. From afar, they look like a flock of glowing birds circling a distant sun, bound by the same silent gravity that holds all things in motion. And when the great galactic merger arrives, when Andromeda and the Milky Way finally meet, these forgotten satellites will not be left behind. They too will be drawn into the cosmic dance, their orbits unraveling, their stars scattered across the newborn sky. Some will be absorbed entirely, their names and boundaries erased. Others will endure, embedded within Andromeda's glowing halo as faint whispers of the galaxies they once were. In the end, their light will remain, quiet, steady, eternal, a part of the new galaxy's luminous heart. They will no longer be forgotten, but remembered in the glow of every star that once belonged to them, shining softly in the endless dark. For years, astronomers believed our galaxy was the larger one. Then the data flipped, and now we know Andromeda outweighs the Milky Way by nearly 500 billion solar masses. It was once comforting to imagine the Milky Way as the dominant presence in our corner of the cosmos, the great spiral that ruled the local group, the galactic sovereign around which all others revolved. For decades, the numbers seemed to confirm that belief. Andromeda, though beautiful, appeared slightly smaller and dimmer, perhaps a graceful cousin, but not the ruler of our region. We saw what we wanted to see: light, symmetry, familiarity. But as the universe so often does, it kept the truth hidden behind the illusion of brightness. The debate persisted quietly for generations. Which galaxy was truly larger? The Milky Way or Andromeda? For much of the 20th century, evidence leaned toward us. We measured their light, their visible disks, their spiral arms. But brightness can lie, and starlight alone tells only half the story. When the tools of astronomy evolved, when Hubble peered across space, when Gaia traced the dance of stars, when ground-based telescopes with adaptive optics pierced the atmospheric blur, we began to measure not what we saw, but what we felt: motion, velocity, the tug of gravity itself. And what the data revealed overturned everything. Gravity told a different tale, one where Andromeda was the heavyweight, its invisible halo vast and deep, enclosing a reservoir of mass beyond anything our galaxy could match. By studying the speed of its stars, the motion of its globular clusters, and the orbits of its satellite galaxies, astronomers uncovered the truth: Andromeda's total mass exceeds that of the Milky Way by nearly 500 billion suns. In the scale of the universe, that's not a small difference. It's the gap between a river and an ocean, between immense and unfathomable. This revelation redefined our understanding of the local group. It meant that Andromeda, not the Milky Way, sits at the gravitational center of our small cluster of galaxies. We don't merely coexist beside it, we orbit together, our trajectories bound by its superior weight. The smaller body always circles the larger, and so, in a way, our galaxy already revolves around Andromeda's invisible influence, following a path that will end not in subjugation, but in merger. The Andromeda paradox is more than a question of size. It is a mirror held up to human perception. For centuries, we judged the cosmos by brightness, mistaking radiance for dominance. But Andromeda teaches a humbler lesson. The universe hides its strength in the unseen. The brightest things are often not the most powerful. The greatest forces are cloaked in darkness, the dark matter that binds galaxies, the invisible gravity that sculpts space, the silent pull that writes destiny in orbits and motion. Even now, the paradox deepens. The Milky Way, it turns out, may be denser, more compact, its stars gathered tightly around a luminous core, while Andromeda stretches wider, more diffuse, its spiral arms flung far into the void. Two galaxies built of the same materials, shaped by the same laws, and yet different, like two verses in a single cosmic poem, each completing the other's rhythm. And perhaps that's the real beauty of the Andromeda paradox, that knowledge doesn't end mystery, it expands it. For every discovery, new questions bloom, not about who is greater, but about how they coexist, how they evolve, how they move together toward a shared future. Andromeda's greater mass does not diminish us. Instead, it reminds us that even giants orbit something larger, that even the vastest spirals bow to deeper gravity. It's a humbling truth that strength often hides in stillness, that darkness carries the greatest weight, and that wonder, not pride, is the true language of the stars. At the center of Andromeda lies a supermassive black hole, a gravitational colossus 30 times larger than the one anchoring our own Milky Way. Its mass exceeds 100 million suns, a silent titan holding an entire galaxy in place. There is a stillness at the center of every galaxy, a silence so profound that it bends the structure of space itself. In Andromeda, that silence takes form as a well of darkness, a point where light ceases, where time stretches into eternity. It sits at the heart of the galaxy like a frozen heartbeat, invisible yet commanding everything around it. Nearby stars whirl in luminous spirals, moving at impossible speeds, as if dancing at the edge of a cosmic abyss. Astronomers first uncovered the presence of this hidden power through motion, through the inexplicable behavior of the stars that surrounded it. They moved too quickly, too precisely, orbiting an empty point with the gravity of 1,000,000 suns. No visible object could explain their paths, no cluster or cloud. Only one thing could: a black hole. Years later, with the help of infrared and X-ray telescopes, that hypothesis became certainty. The center of Andromeda hides a black hole of staggering proportions, one of the most massive known in our galactic neighborhood. If we could see it directly, it would not appear black at all. Around its event horizon, a ring of light blazes, an accretion disk of gas and dust heated to millions of degrees as it spirals inward. The energy released there is unimaginable. Each particle of gas falling into the void becomes a flare of light, brighter than an entire star, shining for an instant before vanishing forever. Across intergalactic space, faint X-rays echo from this process, whispers from a furnace at the edge of physics. This immense black hole is not merely a passive anchor, it is a sculptor, shaping Andromeda's very form. Its gravity organizes the inner stars, pulling them into orbits that form the galaxy's bright central bulge. It stirs the surrounding gas, influencing when and where new stars ignite. Even across thousands of light years, its pull can set entire star clusters into motion. Andromeda's structure, its symmetry, its heart, its slow, elegant rotation, all trace back to this invisible source. And yet, despite its power, the black hole sleeps. Unlike the raging quasars of the early universe, which devoured entire galaxies in torrents of light, Andromeda's core is quiet now. It feeds rarely, a drifting cloud of gas, a wandering star too close to escape. Each feeding sparks a brief flash of radiation before the darkness closes once more. This dormancy is deceptive, for the black hole remains a wound in space-time, patient and eternal. But peace in the cosmos is never permanent. When Andromeda and the Milky Way finally collide, their two central black holes will begin to circle each other, drawn together in a slow, spiraling dance. Over millions of years, they will drift inward faster and faster, until they merge in a burst of gravitational energy so immense it will ripple across the universe itself, a wave through the fabric of space and time. In that future, the two hearts will become one. The foundation of the new galaxy, Milkdromeda, Andromeda's core of fire will merge with our own, forming a single, greater gravity well at the center of everything. The black hole at Andromeda's heart is more than a void. It is a paradox, destruction that sustains, emptiness that gives structure. It is the cradle and the grave of the galaxy, the silent keeper of its history, the promise of its future. To gaze toward that core is to peer into the true heart of the universe, not a heart of flame or motion, but one of gravity and silence, where creation and annihilation become the same eternal pulse. Using the Hubble Space Telescope, astronomers tracked the dance of Andromeda's central stars. Their orbits revealed just how deep its gravity well goes, confirming the galaxy's staggering weight. The center of Andromeda isn't still, it's alive with motion. Thousands of stars whirl around the invisible core in complex, overlapping paths. From a distance, it might look serene, a soft, glowing bulge of light. But up close, it's a storm of brilliance. Stars race around the central black hole at hundreds of kilometers per second, tracing orbits so tight that their paths complete in mere centuries. The Hubble Space Telescope captured these motions with extraordinary clarity, revealing a miniature galaxy within the galaxy, a dense cluster of suns orbiting the unseen giant. By analyzing how their light shifted, red when moving away, blue when drawing near, astronomers could map the velocity of each star, creating a three-dimensional portrait of Andromeda's heart. The results were breathtaking. The stars didn't move randomly, but with precision, as if choreographed by an unseen conductor. Their orbits, their accelerations, even their variations in color told the same story. Beneath them lay an immense gravitational force. The deeper the stars plunged toward the center, the faster they moved, confirming the presence of a massive black hole, one capable of holding an entire galaxy in balance. These observations gave Andromeda's center a new kind of beauty. It wasn't just a distant glow anymore. It was motion, rhythm, music. Each star's orbit became a note, and together they played a cosmic symphony of gravity and light. The melody revealed the truth of the galaxy's weight, not as a number, but as a feeling, a vibration in the bones of the universe. Andromeda's nucleus became a classroom for cosmic physics. By studying it, astronomers refined their understanding of how galaxies evolve, how black holes feed, how energy flows, how balance is maintained between chaos and order. The insights drawn from its motion even helped calibrate models for other galaxies, giving us a universal key to understand how matter behaves under the rule of gravity. There's something poetic about the fact that we can know so much through motion alone. We cannot touch Andromeda, yet we can feel its gravity by the way its stars move. Their orbits speak across the void, whispering the secrets of an immense and ancient structure. In those flickers of light, in those orbits traced over millennia, the truth becomes clear. Andromeda is not a silent figure in the sky, but a living, breathing being, a vast organism of stars in perpetual motion, carrying the memory of creation within every turn. It moves, therefore it is alive. And through its motion, the universe remembers itself. Infrared telescopes uncovered a hidden population of red giant stars, invisible to the naked eye. These ancient suns contribute billions of solar masses, silent witnesses to the galaxy's long evolution. To the human eye, Andromeda glows like a pale, silvery mist against the dark. But that's only a fraction of its truth. Much of its light hides beyond visible wavelengths, where our eyes cannot reach. When astronomers began studying the galaxy in infrared light, they uncovered something astonishing, an entire hidden world of ancient stars, veiled behind dust and time. Infrared light can pierce through the dark lanes of interstellar dust that scatter and absorb ordinary starlight. Where optical telescopes saw emptiness, infrared instruments revealed vast populations of red giant stars, bloated, aging suns nearing the ends of their lives. They burn cooler than young blue stars, their light gentle and dim, their surfaces trembling with the memory of fusion long sustained. These are the elders of Andromeda, luminous ghosts whose glow tells the story of the galaxy's earliest eras. Each red giant began life billions of years ago, back when the universe itself was young and restless. Many formed in smaller galaxies that Andromeda later devoured, carrying their old light into a new home. Their presence is like the voice of history, echoing through the galactic core, soft, distant, but enduring. Together, they add billions of solar masses to the galaxy's weight, a hidden reservoir of matter that only infrared eyes can see. Through telescopes like Spitzer, Herschel, and now the James Webb Space Telescope, astronomers can map these old populations in exquisite detail. They trace Andromeda's structure not through brilliance but through warmth, through the faint heat of ancient suns glowing like embers beneath the brighter blaze of younger stars. The patterns they form reveal the galaxy's age, its cycles of birth and death, and the scars of its violent past. To look at Andromeda in infrared is to peel back its outer skin. You see its skeleton of stars, its hidden anatomy of light. The spiral arms appear softer, rounder, and more filled out, as if the galaxy itself is exhaling the breath of eternity. The young blue stars that dominate visible light give way to the deep red of age and memory. These red giants are the ghosts of a billion forgotten dawns, suns that once blazed with youth, now fading into silence. Yet even in their fading, they contribute to the galaxy's mass, their slow winds enriching space with carbon and oxygen, seeding new generations of stars. They are the bridge between what was and what will be. Every galaxy holds such ghosts, but in Andromeda, they shine with a special poignancy. Their faint warmth crosses 2.5 million light-years to reach us, a quiet testament that even the oldest light still travels, still endures. In their glow, we see the passage of time made visible, the memory of a universe that never truly forgets. Andromeda's enormous mass didn't come from birth alone. Over billions of years, it devoured smaller galaxies, absorbing their stars, dust, and dark matter. Its size is the result of cosmic hunger. Galaxies are not gentle beings. They grow not only by gathering gas from the void, but by consuming one another. This is the secret history written into Andromeda's shape, a legacy of violence disguised as beauty. Beneath its graceful spiral arms lies a record of countless collisions, mergers, and absorptions. In the early universe, galaxies were smaller, more fragile, more easily scattered by gravity's tides. Over time, the largest began to feed on the weak. Andromeda was one of them, a predator among the stars. It collided with and consumed dozens of smaller galaxies, tearing them apart and weaving their stars into its own structure. Some were stripped cleanly, leaving only faint halos of stars. Others plunged deep into Andromeda's core, mixing their light and dust with its own, reshaping the galaxy's center. Astronomers have found the evidence everywhere. Streams of stars looping around Andromeda's outskirts mark the trails of these ancient meals, elongated remnants of entire galaxies torn apart by gravitational tides. Their orbits still shimmer faintly, tracing the invisible web of the past. Even the composition of Andromeda's stars reveals the story. Older, metal-poor stars, relics of primitive galaxies, lie interwoven with newer, richer ones, proof of a long, layered history of galactic cannibalism. In a way, Andromeda's hunger mirrors the universe itself. Creation and destruction are not opposites in space, they are partners. When a galaxy consumes another, it doesn't annihilate it, it incorporates it. The stars live on, the gas fuels new suns, and the dark matter joins the larger halo. The universe wastes nothing. Simulations of Andromeda's growth reveal a tapestry of violence and rebirth. Over 10 billion years, its mergers built the vast spiral we see today. Its graceful arms are shaped not by serenity but by chaos, slowly healed, the outcome of repeated collisions smoothed over by gravity's patience. The galaxy's very symmetry is deceptive, a mask hiding its tumultuous evolution. Even now, Andromeda's feast continues. Dwarf galaxies at its edges, like M32 and NGC 205, are slowly being drawn in, their stars stretched into filaments of light. In a few billion years, they'll be part of the larger whole, their identities dissolved into Andromeda's luminous heart. To call this hunger monstrous is to misunderstand the cosmos. Growth is not cruelty. It's nature's way of sculpting scale. Andromeda's enormity is not gluttony but endurance, the record of time itself accumulating in stars. When we look at it tonight, glowing faintly beyond the Milky Way's edge, we're not seeing a single entity. We're seeing the ghosts of dozens, maybe hundreds of galaxies, fused into one magnificent being. And in 4 billion years, when the Milky Way joins that gathering, we'll become part of the same ancient story, another chapter in the universe's endless appetite for creation. Faint tidal streams wrapping around Andromeda reveal its violent past. Each stream marks a galaxy it consumed, each one a scar written across the stars. At first glance, Andromeda looks whole, a perfect spiral suspended in the dark. But look closer, and you'll see the faintest of threads stretching far beyond its visible edges. These are the remnants of long-vanished galaxies, rivers of stars torn apart by gravity and left adrift in slow, luminous arcs around their conqueror. Astronomers first detected these ghostly structures in deep exposure photographs that reached far beyond the galaxy's bright disk. The stars in these streams are ancient, their light faint and reddish, but their pattern is unmistakable. Great loops and ribbons wrapping around Andromeda's halo like trails of smoke. Each one is a fossil, a scar left behind by a collision that took place billions of years ago. By studying the position and motion of these tidal streams, scientists can reconstruct Andromeda's violent history. Some streams are the remnants of tiny dwarf galaxies swallowed whole. Others trace the paths of larger galaxies that grazed Andromeda's edge before being shredded and absorbed. Each has its own rhythm, its own orbit, its own time of death. Computer simulations show how these interactions shaped the galaxy we see today. Each merger sent ripples of gravity through Andromeda, distorting its spiral arms, altering its rotation, even enriching its stars with new elements. Over time, gravity smoothed the chaos, but the evidence remained, faint, beautiful, undeniable. Some of the most striking of these features form vast, ring-like structures hundreds of thousands of light-years across, glowing softly in starlight. They may have originated when Andromeda collided with a galaxy half its size, billions of years ago. The smaller one was torn apart, its stars scattered into space, while its core sank into Andromeda's heart. The halo of Andromeda, that immense, invisible sphere of dark matter, holds the memories of these encounters. It's not just a structure of gravity, but a record of time. The tidal streams are its handwriting, delicate strokes drawn across eternity. To the human eye, they're barely visible, but through telescopes, they tell a story of unending change. Galaxies grow through conflict, but they also heal. The streams will eventually fade, their stars blending seamlessly into the halo, their separate identities lost to the collective whole. And yet, in this loss lies beauty. Every stream of light is both a remnant and a rebirth, the last whisper of one galaxy becoming part of another. In the slow language of the cosmos, Andromeda's scars are not wounds, but signatures, proof that even destruction, in time, becomes creation. Andromeda shines with the combined glow of 1 trillion ancient stars. But its light isn't uniform. Its bulge glows golden with age, while its spiral arms shimmer with newborn suns. To look upon Andromeda through a telescope is to look across time. Every photon that reaches us has traveled for more than 2.5 million years, crossing the void like a letter from the past. What we see is not what Andromeda is, but what it once was, a frozen image of a moment that has long since passed. And yet, its light still breathes, still flickers with the pulse of life. The galaxy's center burns with a steady amber glow, light from ancient stars nearing the end of their long existence. These are the elders of the galaxy, suns that have burned for billions of years, their fusion slowing, their brilliance mellowing into gold. The bulge that surrounds them is thick and round, a dense city of light where night never falls. There, gravity reigns, and age lingers in every flicker. But as your gaze drifts outward, the tone changes. The spiral arms unfold in sweeping arcs of blue and silver, the hues of youth. Here, Clouds of gas collapse into new stars, bursting into life with fierce radiance. These young blue suns burn hotter, brighter, and faster, scattering their light across the galaxy like fireworks. They are short-lived, but their brilliance defines Andromeda's beauty. Between these extremes, the ancient heart and the restless arms, lies a continuum of light that tells the galaxy's history. Each color marks a different chapter: gold for the old, white for the middle-aged, blue for the new. To study this gradient is to read a story written in starlight, each hue a paragraph in the chronicle of creation. Astronomers use filters and spectrographs to break Andromeda's glow into its components. They find fingerprints of elements forged inside stars: hydrogen, helium, carbon, iron, all evidence of generations of birth and death. In that light is the memory of every supernova, every fusion reaction, every collision. The glow of old light is not just beauty, it's information. It reveals how galaxies age, how they renew themselves, and how the universe recycles matter into endless forms. Andromeda's radiance is a living archive, an entire history glowing softly across the void. When you step outside on a clear night and see that faint blur above the horizon, you are seeing this light. You are witnessing the ghost of 1 trillion suns, each shining long before humanity existed, their glow whispering through time. We were here, and so shall you be. Even dust has mass. Vast lanes of interstellar dust wind through Andromeda's spiral arms, holding enough material to form billions of new stars, invisible yet essential to its total weight. To the naked eye, dust is emptiness, the faint haze that dims starlight and hides distant horizons. But in the scale of galaxies, dust is power. Each grain, smaller than a speck of smoke, carries the potential for creation. In Andromeda, these grains are countless, woven into dark filaments that crisscross its glowing disk. Through a telescope, they appear as soft shadows tracing the spiral arms, rivers of obscurity against oceans of light. This dust is not simple dirt, but stardust, carbon, silicon, and iron forged in the hearts of dying suns. When massive stars explode, they scatter their ashes into space, and over time those ashes cool and clump into microscopic crystals. They drift through Andromeda's arms, mingling with hydrogen gas, forming the raw material for future generations of stars and planets. The lanes of dust shape the galaxy's character. They absorb light from nearby stars, re-emitting it in infrared, giving Andromeda a soft, warm glow when viewed through that spectrum. This radiation tells astronomers how dense the dust is, how warm it's become, and how much new star-forming material it holds. Andromeda's dust weighs billions of solar masses. Invisible though it seems, it contributes significantly to the galaxy's total mass. Without it, Andromeda would be sterile, no clouds to collapse, no stars to form, no planets to rise from the cosmic dark. The dust is both cradle and grave, the residue of death becoming the seed of life. Infrared telescopes like Herschel and Spitzer have mapped these dusty structures in astonishing detail. They reveal colossal regions where dust collects, cold, dense nurseries waiting for the next wave of starbirth. In those hidden realms, gravity will soon compress the dust and gas until fusion ignites anew, and the cycle begins again. And yet, the dust is fleeting. Ultraviolet radiation from newborn stars eventually burns it away, scattering it back into the interstellar medium. What was once shadow becomes light again. To understand Andromeda's dust is to understand the balance between destruction and renewal. Every shining star began as dust, and every dying star will return to it. This quiet exchange, this recycling of light into matter and matter into light, is the heartbeat of the cosmos. Next time you see Andromeda's faint glow, remember, much of that light has traveled through its own dust to reach us. The darkness within it is not absence, but promise, the quiet weight of worlds yet to be born. Beyond the stars lies an immense sea of gas, hot, ionized plasma stretching hundreds of thousands of light years. This halo gas, recently mapped by NASA's Hubble, holds the mass of hundreds of billions of suns. It's easy to think of a galaxy as an island, a self-contained world adrift in emptiness. But Andromeda is surrounded by something vast, an ocean so thin we can't see it, yet so large it outweighs entire galaxies. Astronomers call it the circumgalactic medium, or CGM, a halo of superheated gas that envelopes the galaxy like an atmosphere. This invisible ocean is composed of plasma heated to millions of degrees. It glows faintly in ultraviolet, invisible to our eyes, but detectable by instruments aboard the Hubble Space Telescope. By observing the light from distant quasars passing through this halo, scientists can detect subtle absorption lines, fingerprints of the gas that reveal its composition and density. What they found changed our understanding of Andromeda entirely. The halo extends far beyond the galaxy's stars, more than 1 million light-years in every direction. It contains not just hydrogen, but heavy elements like oxygen, nitrogen, and neon, the ashes of countless generations of stars. This gas is both ancient and dynamic, constantly flowing in and out of the galaxy as stellar winds and supernovae pump energy into the surrounding void. The scale of this ocean is unimaginable. If we could see it glowing in visible light, it would stretch across the sky 6 times wider than the moon. Within it lies enough material to create hundreds of billions of new stars, a reservoir of cosmic potential. But this gas doesn't merely sit still, it breathes. Streams of cool gas flow inward, feeding star formation, while hot, enriched gas flows outward, escaping the galaxy's gravitational pull. The result is a cycle of galactic respiration, inhalation, and exhalation that keeps Andromeda alive. This invisible ocean connects the galaxy to the greater cosmic web. It's through halos like this that matter moves between galaxies, linking them together in a vast network of exchange. And because Andromeda's halo already overlaps with our own Milky Ways, the two galaxies are, in a sense, already sharing the same sea. In that quiet plasma lies the future. When the galaxies finally merge, their halos will mix, their gases combining to fuel an era of new star birth that will illuminate the newborn Milkdromeda. Andromeda's invisible ocean reminds us that what we can't see often holds the greatest weight. Space is not emptiness, it's substance, structure, and story. Between the stars, in the thin, lightless plasma of the halo, the next generation of suns is already waiting to begin. Andromeda dominates the local group, a small cluster of more than 50 galaxies, including our own. Together, their combined gravity binds a region 3 million light-years across. The universe may seem endless, but it's built from families, collections of galaxies held together by the quiet pull of gravity. Our home, the Milky Way, belongs to one such family, the local group, and at its heart stands Andromeda, the largest and most massive of them all. The local group spans a stretch of space roughly 3 million light-years wide, a cosmic neighborhood adrift in a greater cosmic web. Most of its members are tiny dwarf galaxies, dim smudges of light scattered like embers in a cooling fire. But two giants dominate the scene, the Milky Way and Andromeda, each with their own retinue of smaller companions orbiting impatient. Astronomers often compare the local group to a miniature gravitational system, a vast but balanced structure where every galaxy's motion is dictated by the collective mass of the whole. At its edges, the gravitational influence of the group fades into the deeper void, giving way to the pull of neighboring clusters. But within, there is unity. The galaxies are bound, sharing a common future written in the equations of gravity. Between Andromeda and the Milky Way lies empty space, 2.5 million light-years of near-perfect vacuum. Yet even across that vast gulf, the two are connected, their mutual pull subtly bending each other's paths. Smaller galaxies, like the Triangulum Galaxy M33, the third largest member of the group, act as intermediaries, orbiting in the complex gravitational field created by the two titans. This local cluster is our cosmic cradle. Everything we know, every star, every nebula visible to the naked eye, lies within its gravitational bounds. Beyond it, galaxies drift away, carried by the expansion of the universe. But here, gravity wins. The local group is like a pocket of resistance against cosmic expansion, a region where attraction still overcomes the stretching of space. Andromeda's mass defines the balance of this family. Its gravity anchors smaller galaxies, holds them in orbit, and subtly shapes the structure of the group itself. Even the Milky Way's motion is influenced by its neighbors' presence. Both are spiraling slowly toward a shared destiny. The local group is small compared to the great clusters that populate the cosmos, places where thousands of galaxies crowd together. But it is our home. It is the scale on which human imagination first touches the infinite. And at its center, Andromeda reigns quietly, the great monarch of our cosmic neighborhood, watching over a realm 3 million light-years wide. For decades, astronomers debated which galaxy was heavier, the Milky Way or Andromeda. Now, we know Andromeda wins. Its extra mass subtly tilts the balance of our shared gravitational dance. It's a rivalry written in the stars. Two spiral galaxies, mirror images of one another, orbiting in the same corner of the universe, bound by gravity, yet separated by light-years of emptiness. For generations, scientists wondered which of the two was the heavyweight, which one held the greater pull. At first glance, the Milky Way seemed to have the advantage. Its arms looked thicker, its core more compact, its star clusters more numerous. And because we see our galaxy from within, it's easy to believe we inhabit the larger of the pair. But distance distorts perspective, and light can deceive. Over the decades, astronomers refined their measurements, weighing each galaxy not by its glow, but by its motion. They tracked how fast stars orbited their centers, how satellite galaxies drifted in their halos, how gas clouds responded to gravity's call. The data grew clearer, the calculations sharper, and one by one, the numbers fell into place. Andromeda, it turned out, is the heavyweight champion of the local group. Its dark matter halo stretches farther, its gravitational reach extends deeper, and its total mass surpasses that of the Milky Way by nearly 500 billion suns. It means that Andromeda, not the Milky Way, dictates the choreography of our mutual orbit. The balance between the two is delicate, a cosmic seesaw of mass and momentum. Both galaxies pull on each other, warping their shapes, bending their paths through space. The Milky Way tugs back, its own gravity strong enough to slow Andromeda's approach, but not enough to stop it. In time, the pull will win, and the two will merge, a moment when the cosmic balance tips fully toward union. In this slow-motion ballet, there are no victors or losers. Gravity seeks harmony, not conquest. Andromeda's dominance doesn't overshadow us, it completes the picture. Together, the two galaxies form a binary system on a grand scale, two spirals turning toward each other across the centuries, drawn by the same invisible thread that binds all things. The cosmic balance is a reminder of humility. Even on the scale of galaxies, the universe plays by rules of equality and reciprocity. Every pull is met with an equal return, every mass balanced by motion. The Milky Way and Andromeda are partners in this dance, bound not by competition, but by the shared physics of their fate. Galaxies don't stay the same. Over billions of years, Andromeda's mass has grown, and will continue to grow, as it absorbs smaller galaxies drifting through space. Nothing in the cosmos is static. Stars move, planets drift, galaxies collide and merge, and through it all mass flows like a river, shifting from one form to another. Andromeda is no exception. What we see now is only a snapshot of a long evolution, a single frame in a film that began nearly 10 billion years ago. In its youth, Andromeda was far smaller, a compact, turbulent cloud of gas and stars, surrounded by an embryonic halo of dark matter. Over time, it grew through both creation and consumption. Clouds of hydrogen collapsed into new stars, while smaller galaxies fell inward, their material absorbed and reformed into the growing spiral we see today. Every merger left a mark. Faint trails of stars in its halo, ripples in its rotation, bursts of star formation that reshaped its arms. These events were not rare, they were constant. Even now, Andromeda continues to feed. Dozens of dwarf galaxies orbit its perimeter, slowly unraveling as tidal forces stretch them into luminous ribbons of light. The galaxy's mass has increased steadily through these interactions. Simulations suggest that over the next few billion years, Andromeda will gain even more, devouring nearby companions until its total mass reaches nearly 2 trillion suns. This is how galaxies grow, through patience, gravity, and time. But the weight of time is not only physical, it's also luminous. The stars that populate Andromeda tell a story of eras gone by. Some are young and brilliant, burning blue in their spiral arms. Others are ancient, red and dim, survivors from a universe half its current age. Together, they form a living record of cosmic history, a galaxy that remembers. When astronomers measure Andromeda's mass, they are not just weighing matter, they are weighing time itself. Every particle of dust, every atom of hydrogen, every star is a timestamp in the long chronicle of its evolution. And one day, its growth will culminate in the greatest merger of all, its union with the Milky Way. When that happens, the weight of both galaxies will combine and time will begin a new chapter. Andromeda's story teaches us that the universe is not a place of permanence, but of transformation. The galaxy we see tonight is not the one that was, nor the one that will be. It is a moment in motion, a colossal reminder that even the largest things in creation are still becoming. Computer simulations show how dark matter builds galaxies from the inside out. Invisible scaffolding collects gas and dust, birthing stars in its gravitational web. Andromeda's mass reveals the scale of this hidden structure. Every galaxy we see is only half of what truly exists. The other half, the framework that makes galaxies possible, is invisible. It cannot be seen through any telescope, yet its influence is everywhere. This is dark matter, the silent architect of the cosmos. Without it, neither Andromeda nor our Milky Way would exist. Astronomers and physicists have spent decades trying to map this unseen world. Using powerful supercomputers, they simulate how dark matter behaves over billions of years. The results are astonishing. What emerges is a vast, cosmic skeleton, a network of filaments and nodes stretching across the universe. In this invisible web, dark matter gathers like mist condensing into dew, drawing ordinary matter along with it. It's inside these filaments that galaxies are born. Andromeda's immense size is a testament to this structure. Its stars, gas, and dust occupy only the innermost fraction of a much larger dark matter halo. This halo extends for millions of light years, far beyond the edge of visible starlight. It is this hidden skeleton that gives the galaxy its shape, its gravity, its coherence. Computer simulations of Andromeda's formation show how the galaxy grew within this framework. Streams of gas and smaller galaxies flowed along dark matter filaments, merging at the central node where Andromeda now resides. Over time, these inflows built the spiral arms, the halo, the bulge, all anchored by dark matter's silent presence. The halo doesn't simply hold the galaxy together, it governs its future. It dictates how fast Andromeda rotates, how its stars move, and even how it will collide with the Milky Way. When we calculate Andromeda's mass, we are really weighing the dark matter scaffolding that sustains it. Though we cannot see dark matter directly, its influence is everywhere. It bends light through gravitational lensing, alters the orbits of stars, and shapes the clustering of galaxies. The Andromeda Galaxy is one of our clearest examples of this, a masterpiece built on invisible foundations. There's something humbling in this idea that the most massive, most dominant component of our galaxy is something we can't detect except by its pull. It reminds us that most of reality lies beyond our senses. When you look at Andromeda, you're not just seeing a galaxy of 1 trillion suns, you're seeing the surface of an unseen world, a luminous mask stretched over a cosmic skeleton. Beneath that mask lies the true architecture of creation. Silent, eternal, invisible, and profoundly real. By understanding Andromeda's mass, astronomers can better model how galaxies evolve across cosmic time, from the birth of the first stars to the large-scale structure of the universe itself. When we measure Andromeda's weight, we're not just studying a single galaxy, we're unlocking a key to the universe's entire design. Galaxies are the building blocks of the cosmos, and their masses dictate how the universe grows, how it slows, and how it will eventually fade. Andromeda is a window into that process. It's close enough to study in exquisite detail, yet massive enough to represent the great spirals that populate the universe. By learning its true mass, astronomers can test and refine models of cosmic evolution, bridging the scales between local observation and universal law. Early in the universe, just a few 100 million years after the Big Bang, matter began to clump together under gravity. Tiny fluctuations in density, seeds planted in the fabric of space, grew into halos of dark matter. Within those halos, gas cooled, condensed, and formed the first stars. Over billions of years, these halos merged, creating the galaxies we see today. Andromeda's mass reveals how this process unfolded. Its sheer size tells us how much matter gathered in one region of space, and by extension, how the rest of the cosmic web must have evolved. Comparing Andromeda's mass with that of the Milky Way helps astronomers refine estimates of the total mass of the local group and even of the rate at which galaxies merge across the universe. But Andromeda's importance doesn't end there. Its rotation, its dark matter halo, and its gas flows all feed into our models of cosmic expansion. The mass of galaxies determines how space itself curves, how clusters form, and how gravity competes with dark energy, the mysterious force that drives the universe apart. In this sense, Andromeda is both a local neighbor and a cosmic yardstick. It helps us test the balance between the two great powers of existence, gravity and expansion. And as we refine its mass, our understanding of the universe's fate grows clearer. Will gravity one day overcome expansion, pulling everything back together in a big crunch? Or will dark energy continue to accelerate the cosmos until all galaxies drift beyond one another's light? The answers begin here, in the quiet light of a single spiral galaxy hanging in the dark. By measuring Andromeda, we measure the strength of creation itself, the forces that built the stars, the galaxies, and the vast web that connects them all. To know one galaxy deeply is to touch the heartbeat of the entire cosmos. Andromeda's mass isn't just a number, it's a bridge between the infinite and the intimate, a reminder that in studying one distant world, we come closer to understanding the fate of all. The Gaia spacecraft has mapped Andromeda's motion in exquisite detail, measuring not only its speed but the subtle drift of its stars. These data transformed a blur into a living, moving being. For centuries, Andromeda was a mystery painted in light, a beautiful, motionless swirl beyond the reach of human understanding. But today, thanks to the precision of modern instruments, we can watch it breathe. The European Space Agency's Gaia spacecraft, launched in 2013, has turned that distant glow into a three-dimensional masterpiece. Gaia's mission is to measure the positions and motions of more than 1 billion stars, both in our Milky Way and beyond. By tracking their movement over time, it builds a dynamic map of the cosmos, a movie instead of a snapshot. For the first time, astronomers can see Andromeda not as a static picture, but as a galaxy in motion. Each star within it moves with purpose, following the invisible currents of gravity. Some drift outward, some spiral inward, others cross paths in long, graceful arcs. Gaia has measured the subtle changes in their position, shifts so small they're comparable to the width of a human hair seen from hundreds of kilometers away. From those minute displacements, astronomers reconstruct Andromeda's full 3D motion across space. The results are stunning. Andromeda isn't just approaching us, it's rotating, tilting, and flexing. Its disk ripples like a slow-moving wave, shaped by ancient collisions and ongoing interactions with nearby dwarf galaxies. The data reveal patterns of stellar migration, the gentle circulation of stars between the arms, the slow drift of matter from the core to the edges. This new map has transformed our understanding of galactic anatomy. We can now trace how Andromeda's mass is distributed, how its spiral arms twist, and how its halo responds to gravitational tides. In the hands of scientists, Gaia's data has turned the galaxy from a distant wonder into a living system, full of movement and memory. Andromeda's story is no longer frozen in time. Each data point, each measurement of starlight and motion is a heartbeat, proof that the galaxy lives, evolves, and breathes across the ages. When we see it now, we're not looking at a faraway island of light. We're witnessing a living organism, one that spins, drifts, and reshapes itself in the slow rhythm of eternity. Thanks to Gaia, the blur has become a being, and the night sky a map of motion. Gravity isn't just force, it's geometry. The mass of Andromeda bends space-time itself, shaping how light and matter move across millions of light years. When we think of gravity, we often imagine it as a pull, an invisible attraction between objects. But in truth, gravity is not a force in the conventional sense. It is the shape of reality itself, curved and sculpted by mass. Einstein revealed this a century ago, that everything with mass bends the fabric of space-time, and that objects move not because they are pulled, but because they are following the contours of that curvature. Andromeda, with its 1.5 trillion solar masses, is a cosmic sculptor of the highest order. Its dark matter halo, its black hole, its trillion stars, together they warp the geometry of the universe across unimaginable distances. Every photon that passes near it, every smaller galaxy that drifts by, every star that orbits its center, is moving along a path dictated by the curvature of space itself. If you could see gravity, Andromeda would appear not as a flat disk of light, but as a deep well in the fabric of space-time, a vast depression whose slopes stretch for hundreds of thousands of light years. Stars move along those slopes like marbles circling the inside of a bowl, held in eternal orbit by the shape of reality itself. Light, too, feels this geometry. As it travels past Andromeda, it bends, subtly changing its course. Astronomers call this gravitational lensing, one of the most direct proofs that space can curve. Even faint background galaxies behind Andromeda appear distorted, stretched by the invisible hand of its mass. Through these distortions, scientists can trace the distribution of dark matter that gives Andromeda its gravitational form. The idea is humbling. The galaxy doesn't merely exist in space, it defines space. Its mass determines how time flows, how light bends, how motion unfolds. The stars orbit because they must. The fabric itself tells them where to go. To grasp Andromeda's mass is to grasp this truth, that everything we see, from the paths of planets to the swirl of galaxies, is not random motion but geometry in motion. The cosmos is a living sculpture, one carved not by hands but by mass and curvature. When you gaze at Andromeda in the night sky, you're seeing more than a galaxy. You're seeing a distortion of time and space so immense it shapes the destiny of two galaxies, including our own. The night sky is a map not of objects, but of geometry, and Andromeda is one of its most beautiful curves. In 4 billion years, the skies of Earth, or whatever replaces it, will fill with Andromeda's spiral arms. The two galaxies will stretch and twist before merging into one. Our universe moves in slow motion, but its choreography never ceases. Even now, Andromeda draws closer, racing toward us at 110 kilometers per second. It sounds fast, but across the vastness of space, it's a crawl. Yet in time, that crawl will bring the two great spirals face to face. In the deep future, long after the continents of Earth have shifted and the sun has grown hotter, a strange glow will appear in the night sky. It will begin as a faint smear, brighter than the Milky Way's band. Over millions of years, it will expand, revealing structure, two great spiral arms curling like luminous waves. Andromeda will no longer be a distant neighbor. It will fill the heavens. Then, the galaxies will touch. Their halos, already overlapping today, will merge first, followed by their outer stars. The collision won't be violent in the human sense. The space between stars is too vast for direct impacts. Instead, the two galaxies will pass through each other like ghosts, their stars simply changing orbits. But gravity will twist them both, warping their shapes, pulling long tidal tails that shimmer with new star formation. Gas clouds will crash together, collapsing into brilliant clusters of newborn suns. For a while, the combined galaxies will blaze more brightly than ever before, a brief renaissance before they settle into calm. From any surviving world, the sky will be ablaze with light, rivers of stars, veils of color, a panorama too vast for words. This is not destruction, it is renewal. The Milky Way and Andromeda are destined to become one. A new, larger galaxy, reshaped by the merger's slow dance. The process will take billions of years. But in cosmic terms, it's just a moment of transformation. And when it ends, the galaxies as we know them will be gone, replaced by something greater. Two spirals will have become one. Their stars interwoven, their histories fused. The universe will continue, indifferent and beautiful, and new observers, wherever they may be, will gaze upon a sky that no longer belongs to the Milky Way, but to something new. The collision is inevitable. It is not tragedy, but destiny, the next verse in the poem of creation written across the stars. When the collision completes, our galaxies will merge into an elliptical supergiant, billions of stars forming new constellations under an unfamiliar sky. The name sounds almost whimsical, Milkdromeda. Yet it represents one of the most profound transformations in the history of our universe. Two vast galaxies, the Milky Way and Andromeda, will merge, their shapes erased and rewritten by gravity into something entirely new. After billions of years of slow approach, the final embrace will be a ballet of beauty and chaos. The spiral arms will twist into long filaments, stars flung into wide orbits before gravity draws them back. At their centers, the supermassive black holes will spiral toward one another, radiating gravitational waves across the cosmos until, at last, they merge in a burst of energy so immense that space-time itself will ring. The result will not be a spiral but an elliptical galaxy, a smooth, radiant oval glowing with the light of 1 trillion suns. Its arms will be gone, its disk dissolved into a halo of stars. Yet within it, new systems will still form. Stars born from the wreckage of colliding gas clouds, planets coalescing from dust recycled through countless generations of creation. Milkdromeda will be larger, brighter, and more massive than either of its parents. From within, the view will be awe-inspiring, the night sky awash with stars. Constellations will vanish, new ones will take their place, written by the gravity of the new galaxy's shape. Over time, the chaos will fade. The elliptical will settle into balance, a serene glow adrift in the darkness. The traces of its violent birth will fade into harmony, two lineages united into one galactic soul. Perhaps, somewhere within that future galaxy, new civilizations will look to the sky and wonder where they came from. They'll study the motions of the stars, the structure of their world, and find the fingerprints of two ancient spirals, the Milky Way and Andromeda, whose union made their existence possible. The birth of Milkdromeda will mark the end of one era and the beginning of another. It's a reminder that even in the grandest scales of existence, creation and destruction are one and the same, two sides of the same infinite cycle. And as the new galaxy drifts quietly through the cosmos, glowing with the combined light of 2 trillion stars, it will carry within it the memory of everything that came before, the starlight of both our homes, joined forever in the silence of space. At the centers of both galaxies, their supermassive black holes will spiral together, releasing energy greater than every star combined, a gravitational symphony echoing across the cosmos. Every galaxy carries a secret in its heart, a region of darkness so dense, so powerful, that even light cannot escape. The Milky Way has one. Andromeda has one too. Each black hole anchors its galaxy, holding billions of stars in place through its immense gravity. But when these galaxies merge, so too will their hearts, in one of the most extraordinary events the universe will ever witness. As the galaxies draw near, their stars begin to mingle, their gas clouds collide, and their black holes drift toward each other, pulled together by their shared gravity. At first, the distance between them will be measured in tens of thousands of light years, then thousands, then hundreds. Slowly, inexorably, they will close the gap. Each black hole will tug at the stars around it, forming swirling disks of hot gas that glow brighter than any single star. As they near, they will begin a slow dance, orbiting one another in a spiraling ballet, circling ever closer, converting their motion into ripples in space-time, gravitational waves. These waves will ripple outward at the speed of light, stretching and squeezing the fabric of the cosmos itself. When they finally collide, the resulting burst of gravitational energy will dwarf every star, every supernova, every quasar combined. For a brief instant, the entire universe will tremble, not in light, but in gravity. What remains afterward will be a single, even more massive black hole, a new heart for the newborn galaxy, Milkdromeda. Its event horizon will span hundreds of millions of kilometers, its gravity so immense that time itself will slow near its edge. Around it, stars will form new orbits. Gas will settle into a calm disk, and the galaxy will find balance again. This cosmic collision of black holes will be silent to our ears, yet the gravitational waves they send out could one day be heard by future detectors, the deep, resonant hum of the universe itself singing in low tones. It will be the final note in a long cosmic song, marking the end of 2 galaxies and the beginning of one. The merger of these black holes reminds us that even in the darkest places, creation and beauty exist. Out of collapse comes harmony, out of destruction, form. In the silence of space, the cosmos will ring with their union, a gravitational chord echoing through eternity. During the merger, countless new stars will ignite as gas clouds collide. When galaxies collide, they do not destroy, they create. The meeting of the Milky Way and Andromeda will unleash one of the greatest bursts of star formation in cosmic history. Clouds of gas and dust, once drifting peacefully through interstellar space, will crash together under gravity's pressure. Shockwaves will compress the gas until nuclear fusion ignites, and newborn stars will burst to life like sparks in a cosmic firestorm. This stellar bloom will be magnificent. Regions that were once calm will erupt in color, blue, white, and gold. Superclusters of stars will emerge where the gas is densest, forming dazzling new constellations that light up the dark like cities in space. For tens of millions of years, Milkdromeda will shine brighter than any galaxy in our local group. But with creation comes destruction. As new stars are born, old ones will die. Massive suns, their fuel exhausted, will collapse and explode as supernovae, scattering heavy elements into the interstellar medium. Those ashes will become the raw materials for planets, moons, and perhaps one day, life. It's a cycle written into the laws of physics. Collapse leads to compression, compression to birth, birth to death, and death to renewal. The galaxy will not merely survive the collision, it will thrive because of it. The very chaos of the merger will be the catalyst for creation. If there are observers, then, perhaps not on Earth, but on worlds yet unformed, They will see a night sky transformed, no longer a narrow ribbon of the Milky Way, but an ocean of stars in every direction. The heavens will glow brighter than any era before, filled with light born from collision. For a brief time in the scale of eternity, the universe will seem alive with fire. A billion new suns rising together, illuminating the darkness. Then, slowly, the blaze will fade. The gas will be used up, the stars will settle, and Andromeda will grow calm again, shining softly in the infinite dark. The death and rebirth of stars remind us that even endings are beginnings. Every atom in our bodies was once forged in such explosions. When Andromeda and the Milky Way unite, the same process will begin anew, the universe continuing its endless cycle of creation through destruction. The new galaxy will be heavier still, a fusion of billions of worlds, carrying the memories of both galaxies that gave it life. When the final spiral fades and the chaos of collision settles, Andromeda will emerge, vast, luminous, and serene. Its total mass will exceed 2 trillion suns, a fusion of everything the Milky Way and Andromeda ever were. It will be a monument to time itself, the product of billions of years of motion, gravity, and change. The new galaxy's structure will differ from its parents. Gone will be the delicate spirals. In their place, a massive elliptical glow, smooth and timeless. Its stars will orbit in gentle ellipses, no longer confined to a single disk. The central black hole, newly merged, will anchor it all, a silent heart beating with the rhythm of gravity. Every star, every planet, every dust grain will be a memory, fragments of 2 galaxies intertwined. The Milky Way's clusters, Andromeda's arms, their lost satellites and consumed dwarfs, all will find new homes in the unified whole. The halo surrounding Andromeda will stretch for millions of light years, enriched by the remnants of both lineages. In this new galaxy, star formation will slow over time. The gas will thin, the stellar nurseries will fade, and the light will mellow into gold. But even as the brightness dims, the weight will remain, the quiet mass of history compressed into one colossal being. From within, the view will be majestic. Planets orbiting new suns will look up to a sky thick with stars, brighter than any night humanity ever knew. The constellations will be unrecognizable, reimagined by time and gravity. But above them all, the same cosmic truth will endure. Everything changes, yet nothing is truly lost. The weight of the future is not a burden, it's a legacy. Andromeda will carry within it the essence of both galaxies, their stars, their dust, their histories. Even the faintest atoms of ancient worlds will continue to drift within its arms, part of a greater whole. And as it sails quietly through the dark for eons to come, the merged galaxy will stand as a reminder that creation never stops. The universe grows heavier not with age, but with memory. Every collision, every spark, every heartbeat of starlight, adding to the grand, unending weight of existence. To know Andromeda's mass is to measure our own fate. Its gravity defines not only its shape, but the destiny of the Milky Way itself. Every number the astronomers record, every data point, every calculation of rotation speed or halo mass, carries more than scientific weight. It carries prophecy, for when we measure Andromeda, we are, in truth, measuring the path of our own galaxy, our own stars, and ultimately, our own existence. Gravity doesn't simply bind stars to galaxies, it binds galaxies to destinies. The pull that gives Andromeda its mass also governs the slow, inevitable spiral that will bring it and the Milky Way together. Its invisible hand stretches across the void, drawing us closer with every passing second, a journey that has been unfolding for billions of years and will continue for billions more. In the scale of human life, that seems impossibly distant. But in cosmic time, it's already happening. The future merger, the creation of Andromeda, is written in every curve of Andromeda's rotation, every faint wisp of its halo, every pulse of starlight it emits. To measure Andromeda's mass, then, is to read the language of destiny, the geometry of our shared future. Its gravity is our future orbit, our shared fate, the reason that one day our skies will bloom with the light of another galaxy. Science, in this way, becomes poetry. Numbers become metaphors for time. We're not just calculating how much Andromeda weighs, we're calculating the rhythm of eternity. The mass tells us how fast it approaches, how violently it will merge, and how the newborn galaxy will form. It tells us, in measurable certainty, that nothing stands still, that even the stars we see as eternal are part of a larger movement toward transformation. And yet, there's comfort in that knowledge. For if the universe teaches us anything, it's that change is not loss, but continuation. Just as Andromeda's gravity defines its structure, so too does it shape our destiny. The two galaxies are bound by more than matter, they are bound by meaning. The measure of Andromeda's mass is also the measure of our shared journey through the cosmos, a reminder that we're participants in something vast and beautiful, far beyond ourselves. When we weigh Andromeda, we weigh the story of our own becoming. Even as we study Andromeda, countless galaxies beyond it continue their own dances, each weighed down by dark matter, each drawn toward unseen futures. Andromeda may dominate our local skies, but it is just one actor in a far grander play. Beyond it lies the endless sprawl of the cosmos, clusters of galaxies bound together by gravity, filaments stretching across space like threads of light, and vast voids where nothing at all seems to exist. The local group is merely one scene in an infinite theatre. As our telescopes gaze outward, we see galaxies like Andromeda in every direction, spirals, ellipticals, and irregulars, each with its own story, each following the same physical laws that govern our neighbour. Some are colliding, some are being born, some are slowly fading into silence. The dance of galaxies is a universal rhythm, repeating itself everywhere and forever. Even now, as we ponder Andromeda's mass, other galaxies are merging in distant corners of space. Some will form structures even larger than Milkdromeda, colossal ellipticals that dominate their clusters. Others will dissolve entirely, stripped of their stars by the tides of cosmic gravity. The universe is a web in motion, each thread vibrating with energy, each node a galaxy writing its own chapter in time. Dark matter is the conductor of this symphony, unseen, yet orchestrating every move. Its filaments stretch across hundreds of millions of light years, connecting Andromeda, the Milky Way, and galaxies we will never see. Through it flows the hidden gravity that shapes everything, the quiet scaffolding of creation itself. When we watch Andromeda, we are not just looking at a single galaxy. We're witnessing a universal pattern, a glimpse of the infinite repeating in miniature. Our telescopes, our curiosity, our questions, they are the universe observing itself, reflecting on its own vastness through the eyes of beings made from its stardust. Every galaxy's story is part of the same eternal narrative: creation, growth, collision, rebirth. And somewhere, in a distant sky, another civilization may be looking up at their own Andromeda, wondering, as we do, what lies beyond. The cosmos watches and waits. And in that vast silence, everything moves together: galaxies, stars, atoms, and thoughts, all pulled by the same invisible rhythm that binds existence itself. Andromeda isn't just another galaxy. It's our twin, our destination. When we look at it through our telescopes, we aren't seeing a stranger. We're seeing the reflection of what we'll one day become. It hangs in the night sky like a whisper, a smudge of light, delicate and silent, yet ancient beyond comprehension. For most of human history, it was thought to be a cloud, a ghostly nebula adrift among the stars. Only in the last century did we learn the truth. It is another galaxy, nearly identical to our own, shining across the gulf of space like a mirror. Its spiral arms, its clusters, its dust lanes, all echo the structure of the Milky Way. It has its own worlds, its own suns, perhaps its own forms of life looking back toward us. In Andromeda, we see not only the universe as it is, but the universe as we are, a reflection of cosmic symmetry. There's something deeply poetic in this twinship. For billions of years, our galaxies have circled one another like distant siblings, unaware yet intertwined. Now, as we come to understand the full extent of Andromeda's mass, we realize that this relationship is not symbolic, but literal. Its gravity will one day pull us in, the mirror will merge with its reflection, and the two will become one. When that day comes, neither the Milky Way nor Andromeda will exist as we know them, but in their place will rise something new, a single, luminous galaxy carrying the legacy of both. The reflection will become reality. As we gaze at Andromeda from our small world, we're seeing across both space and time. We're looking at the past and at the future. The light that reaches us tonight began its journey when our ancestors first learned to walk upright, and the merger it foretells will happen long after our descendants have become something else entirely. In Andromeda's faint glow, we see our story, the story of connection, transformation, and destiny written across the stars. It is both a window and a mirror, and when we finally meet, the cosmos itself will remember that once, two galaxies looked across the dark and saw themselves in each other's light. We have sailed a slow, starlit river tonight, first tracing the faint smudge of Andromeda until it became a continent of light, then feeling the pull of its hidden weight, the dark halo that holds 1 trillion suns in place. We watched how astronomers learned to weigh the unweighable, reading motion and ghostly gas, globular clusters and satellite streams, and in those movements we found the truth. Andromeda is heavier, older, and more commanding than we once believed. We imagined the quiet streams of stars tugged from their homes, the debris of devoured galaxies that wrote the history of a cosmic appetite, and we glimpsed a future when two spiral cities, our Milky Way and Andromeda, fold into one gentle, slow embrace, the birth of Milkdromeda. Remember the simple, astonishing things we learned. Mass is measured by motion, not light. Most of a galaxy's weight hides in dark matter and hot gas. Weight changes destiny. For stars, for galaxies, for the path of time itself. These facts are not cold numbers, but soft threads that stitch our future into the fabric of the universe. They remind us that we are small and, at the same time, intimately connected to events that unfold on scales both terrifying and tender. As you settle now, let gratitude soften the edges of curiosity. Be grateful for the eyes we have, the telescopes and the minds that translate faint photons into stories of origin and arrival. Be grateful for this moment, for the luxury of imagining futures written in gravity, for the gentle knowledge that the cosmos is not indifferent but full of narrative. Breathe slowly. Picture the pale swirl of Andromeda, growing calm at the edge of sight, its weight spreading like warm twilight across a sea of stars. Let that image fade into a soft, endless dark that holds everything with quiet hands. Sleep now, carried by the steady, ancient pull of galaxies. Good night.